everyone. Today we'll be studying chemical changes and reactions. First, what is chemical change? So, chemical change is a permanent change. What it is? A permanent change. Chemical change. First, that it is a permanent change. Second, that in this change the chemical composition will also change as the reaction will take place. So chemical composition changes. Third thing, that new substances form. Of course, suppose first second is form. Suppose if we take curdling of milk, in that also if we are taking milk with some, we take a few starch or something for the curdling. So if we leave that, then we'll get a new substance, the curd, the yogurt. Similarly, in this also the same thing happens. If there is some product, if there is something, so any substance which is undergoing a change, it will give new substance. It will not be the previous ones. Now, one more thing, that this change is both reversible also and non-reversible also. But generally, generally, it is non-reversible. Okay? It is non-reversible. So this is what is chemical change. If we go into the characteristics of this chemical change, there might be many things similar to this only. What is chemical change? So let us name this. This can come under what? Properties. So properties plus definition. Both. Now, next property, we can say that this change can be both endothermic also, exothermic also. Endothermic and exothermic can be either endothermic or exothermic. Now, what does this word endothermic mean? This term endothermic mean. Endothermic means that the heat is absorbed. Means in a particular reaction, heat was involved. There was the use of heat in a particular reaction. Whereas exothermic means the evolution of heat. Heat is released. This is the exothermic reaction. Or the term exothermic means that heat is released, heat is evolved. Next property is that the whatever is the mass mass of reactants is equal to the mass of products. Now, what are these reactants and products? This reactants means substances used for the change. Substances used for the change and products means substances after the change. This is what a products and reactant mean. Then next is that we have studied that what is a chemical bond. Chemical bond means it is the force of attraction where the two atoms of two different molecules bind together. Okay, the bond between two atoms. Suppose we have H here and we have O here. 2H O. When these will be pulled, there will be the force of attraction. This will combine as H2O. So this is what? Bond, chemical bond between the two. This is only chemical bond. Now, what are the conditions necessary for a chemical change? Now, we'll see conditions. We have seen what is a chemical change, what are its properties, characteristics, yes, and the chemical bond. Now, let us see the conditions which are necessary for the chemical change. Okay. Let us see. Chemical change. Okay. First condition is that I'm sorry for my mistake. Notice and I committed such a big mistake. First condition is close contact. means that if there are two substances, for example, we can say what example, lead or iodine? Iodine. Okay. For example, lead nitrate. Lead nitrate has to react with potassium iodide. Now, the formula for lead nitrate is PbNO3 whole twice. Has to react with potassium iodide, Ki. Ki. Whatever it gives, that is the another case. But suppose if we are keeping lead nitrate here and potassium iodide here, they are not in contact with each other, so this reaction will not take place. But if this lead nitrate is coming in contact with this potassium iodide, then this reaction will take place. So two substances must be in close contact. Now, lead nitrate is white in color or yellow in color? Yes, lead nitrate is white in color and potassium iodide is also white. So when this will react, it will give potassium nitrate. Why? Because this is reacting, so this will bind with this will make a bond with this. So it will be KNO3 plus PbI2. Now let us balance it. Here 2, here 2. Balanced? Yes. Now what is it forming? Potassium nitrate and lead iodide. Now this lead iodide will be in white color. White color or yellow? Yellow color. Please do not say understand and then see. Okay. Now, second is that it should be in solution form, because it's not necessary that in each case it will be in solution form, but there are some cases where the reaction will take place in their solution form only. So second, solution form. NaCl plus AgNO3. If these are the reactants, then what happens that if this is in the solid form, then it will not react. But as we make it dilute, we add water to it, means we make it aqueous, then it will react, giving AgCl and NaNO3. Now if we are taking this will be a precipitate. There is a term called precipitate, and we denote precipitate with downwards arrow. Means precipitate means that it is in the form in insoluble form. Means now if any precipitate is formed, then it cannot be dissolved in any solution, in any liquid. So it is an insoluble solid, okay, which cannot be dissolved. This precipitate is a white color precipitate. Now third is heat. There are some reactions which will take place only when we heat it, especially if there is any compound and we have to separate it, then we you produce heat, then we give heat to them. Sorry, then we give heat to them. So let us see. There is some space. Here. For example, CuC3, copper carbonate. If we take copper carbonate and we want copper oxide and carbon dioxide from this, until and unless we give heat to it, it will not produce only. So this symbol, this delta symbol is used for heat, that we are involving heat in this. So that means that this is an endothermic reaction. Heat is being produced. Heat is being produced or heat is being involved. Yes, heat is being involved. So this will give CuO and CO2. So this is only what it specifies. Then we have light. The reactions which involve light are known as photochemical reaction. Light does not mean that this lights, LED bulbs. No, light means sunlight. So sunlight enables which process? Photosynthesis. From that, photo is taken, and as this undergoes chemical change, the word chemical is taken. So photochemical reaction. Let us see. Let us see. Photochemical. And here the condition is light. I will be lining it to specify this condition. Now, the process of photosynthesis involves carbon dioxide plus water, which gives glucose, oxygen, and water. So CO2 plus H2O gives sunlight. Gives C6H12O6 plus O2 plus H2O. Now, total. Now we need to balance it. Balancing is must. Now, total carbon in this 6. So let us write 6 to 12. How many oxygen? 6. 6 and 2. 8. 1. 9 only. Okay, let us proceed for the first H2. H2, how many? 12 and 2, 14. Balancing, oh my god. I have to erase this balancing. CO. Your C is 1, your O is 2 plus 2. Your C is 6, H is 12 plus O is if we do into 6, this O will also be into 6, 12 and 1, 13. So 6 is here, no, but here also we'll, if we multiply this with 6, 12 and 1, 13, 12 and 13 balance. That means we'll have to write 6 here and 6 here. Now coming to hydrogen. Hydrogen 12 plus 2, 14. 7. Even numbers only. Okay, if we take 6 to 12, how many? 2 is the base. 6 to 1, 12. 12, 2. 6 also, yes. 2, 3, 1, 6. 2, 3, 1, 3. So 12 is coming. Means, see here I took 6 for this oxygen because here also oxygen is involved with hydrogen. 2 I took because H2. H is 2 here, H is 12 here, H is 2 here. So 12 to 6. H is 12. That means the LCM for H we'll have to take 12. Either that side or this side. If we take 12 here, this will give 24. Then into 12 here also. Now, here already how much? 13. How many more? 12. 4, no? 24 minus 13, 11. Okay, wait. 24. 12. 12 or say 12 more. Okay. Yes. 2. We need 12 more, no? So 6. 6. Wait. Here if we are multiplying 6, so here also it will be 6. Now check 6 is equals to 6 is equal to 6 is equal to 12 plus 12 is equals to 24 is it 12 plus 12 is equals to 20 is equals to 24 is equals to 68 plus 6. अच्छा यहाँ पे तो 6 2 wait here it is 6 plus 2 plus 1 so in this 2 we have multiplied this one we have multiplied 6 plus 12 plus 6 24 plus 6 plus 6 is equals to 20. Yes. So this balanced. This is a trick for balancing. You all can learn it. 12 below 6 complete. So these are the conditions necessary for a chemical chain. Next, let us study what is catalyst. One more condition is that we can use catalyst. Fifth condition, catalyst. Catalyst means that any substance which speeds up or decreases the rate of any reaction. Any reaction. So this is what a catalyst is. Now, as we are studying what is catalyst, let us also study that this catalyst is segregated, is divided into two types, namely positive catalyst and negative catalyst. Okay, so positive catalyst means the catalyst which will increase. Here I have written speeds up will be under positive catalyst. A negative catalyst decreases. Decreases. Decrease. Here. So this is what a catalyst. Now example, if we take the example, we can take MnO2 Fe2O3 which we used in the wash process. This we used in the wash process Fe3O4. So these are the examples of catalyst. Apart from this, there is one more term, product, promoters. Okay, promoters means that this is not any different thing. This is generally the in addition to the catalyst. Okay, let us see promoters. Where is this part? Promoters. Promoters generally mean that if there is any catalyst, see catalyst, it will improve the efficiency. Okay, there is a catalyst, it will improve its efficiency. Suppose if it is iron, this one, then molybdenum, molybdenum, Mo. If we'll add it, this will act as promoter, which will improve its efficiency, which will help the reaction to be more faster. Okay. Now you may ask, what is the difference between this catalyst and this promoter? The catalyst will not undergo, will not undergo the reaction. This promoter will undergo the reaction. Okay, so this is the only difference between these two. Next, we can discuss that what are the characteristics of chemical reactions. Characteristic. Now, this was the conditions necessary for chemical changes. Now, this chemical changes is also called as the chemical reaction. So, what are the characteristics of chemical reactions? Okay, let's just see those. First characteristic is evolution of gas. Evolution of gas means okay. As we saw that reaction, CuCO here the gas was used, the gas was released. Which gas was released? H2, no, sorry, CO2. This is what? Carbon dioxide, which is a gas. And for the evolution of gas, we use this symbol, upwards arrow. For precipitate, we use downward arrow. Similarly, for evolution of gas, we use upward arrow. Second is that the change of color. Change of color. Second, change of color. Example, Fe plus CuCO3 gives FeCO3. iron is of reddish brown color and this copper carbonate is of green color. So now this copper carbonate, when it will join into this, then this copper will gain reddish brown color and this will have the blue color, green color. So the change is there in the color. First only one element, single, no compound, was reddish brown. This is reddish brown. But this was green, this is blue now. Is it clear? Then we have the change in of state. Change of state. Change of state means liquid, solid, gas. Suppose H2 plus O2, these two are gas, but on reaction they give H2O. It gives H2O. Fourth is formation of precipitate. And we have taken NaCl plus AgNO3 gives AgCl plus NaNO3. In this was the precipitate. Which color precipitate? White color precipitate. So this way the formation of precipitate takes place. So the characteristics of chemical reactions are: first, evolution of gas. The gas is released. The symbol of evolution of gas is upwards, change in color, change of color. This was first green, then it became blue. Here, change of state. This was gas, but on reaction they became liquid, water. Now, formation of precipitate. These are two compounds in their aqueous state. This is also in aqueous. And this is what? Precipitate. Precipitate. White precipitate. So this is the characteristic. Next, we'll see. So let us discuss the types of chemical reactions. So mainly there are four types of chemical reactions, amongst which the first one is the composition reaction. Composition, we call it composition also, combination also, but the suitable or the more appropriate one is combination reaction. Means that there will be two or more reactants, but the one product will only be there. Heat will be absorbed or released. Means we can take one example of sodium and oxygen. Example 1. Sodium and oxygen. They give any H2O only when it is heated. Only when it is heated. This happens. This the heat is used up. Second, that we can take the example of potassium oxide. This also absorbs heat. P2, P3, P2O5. Then here it will be 5. Yes. So these are the two examples in which heat will be absorbed, but it will give only one product. Another where heat will be released is when any acids is like when any acid is there for the reaction, like in the process of photosynthesis also, glucose is one form and rest are the gases. In photosynthesis, heat is released. So this is the combination reaction. Now let us see decomposition reaction. Decomposition reaction. Reaction. As in this, there were 2 or more reactants in combination reaction. But in decomposition reaction, there will be only one reactant. So, one reactant. But in combination reaction, there was only one product. But in this, there will be more than one product. 2 or more. More than one product. One product. In this, heat was absorbed. In this also, heat will be absorbed or released. Now, for example, CuCO3 gives, in the presence of heat, gives CuO plus CO2. So this is clear. Then second example is HGO. again in the presence of heat will give Hg and O2. Okay, so these are the two examples of decomposition reaction. Basically, decomposition reaction is that there is a group of anything and we are separating it. Suppose there are two friends, so they'll work everything with togetherness, with unity. So they'll always be together. But what we are doing, we are separating them. For separating, we'll require some energy to separate them, so like that, so then they'll be separated. Similarly here also, as there is CuCO3, they are like two friends, they are like friends. So we are applying some energy, that is heat energy, and separating them into copper oxide CuO and carbon dioxide CO2. Similarly for mercuric oxide also. This HgO is for mercuric oxide. Okay. Now, if we are talking about decomposition, there is one term used here for in this decomposition reaction, which is thermal decomposition. Thermal decomposition means the reaction in which they are using the heat. So these reactions will come under thermal decomposition. Now you will think that if this is the case, then every decomposition reaction should be named thermal decomposition. No, there are some decomposition reaction which is not using heat energy. For example, decomposition of water, H2O. When electrolysis, when electric current is passed in the presence of electric current, then only this complete water decomposes into H2 and O2. Okay. Similarly, AgCl2 in the presence of sunlight decomposes into Ag and Cl2. So this is the examples. Now we'll see the decomposition of metal hydroxides. Let us see. These are the important topics of this chapter which we'll deal right now. The questions from these will be asked in any form, but in any pattern, but there will be metal hydroxides. You know the metallic series, the reactivity series. Okay. Aluminium, iron. Then in between this many metals come like zinc, iron, zinc, lead, tin. Okay, I'm writing that also. Alright. Fe and then hydrogen and then below this is least reactive, this hardly reacts. Now let us see this. So if we'll take the metal hydroxide of potassium and sodium, these are stable to heat. This will not react. Stable to heat. This will not react. But if we take the hydroxides of calcium, magnesium, aluminium, zinc, iron, lead, then it will react. It will react. I'm removing hydrogen from here. Okay. Because at some cases copper will also react. These all will react, giving their oxides and water. For example, copper. Plus H2O. But if we take the hydroxides of silver, gold till silver, hydroxide till silver, then it will not give their oxides. Okay. Again, I had written the reactivity series, but till which element it will work and that. Till how it will work. Okay. Now, if we talk about this, giving these will react, giving metal, oxygen, and water. For example, AgOH will give Ag plus O2 plus H2O. Okay. 2 over here. Oh, here no. It will be 4 balanced. So this is in the case of metal hydroxides. But if we take metal carbonates, it will be different. I'm not dropping this part to show the difference. The carbonate of potassium and sodium, again it will be stable to heat. So in these two cases there is no difference. But in the case of calcium, magnesium, aluminium, zinc, lead, tin, iron, copper, it will react by producing their oxide, again their oxide, but not water, carbon dioxide gas. Their oxide and carbon. This is also one side of carbon. Okay, so the reaction will be, again I take copper. Okay, I'll take another metal, say calcium. Calcium carbonate will give CaO plus CO2. The balancing it is difficult. Okay, I'll spread it and write it. Three to 6, 2. If we add to here, 4. Oh, 4. Very challenging task, isn't it? I'll have to balance it. See, calcium. Okay, I got my mistake. I am sorry. I had taken calcium carbonate, right? Yes. So 2 balanced. Okay. Then, if we take for mercury and this is silver, it will get metal, oxygen, and carbon dioxide. Means these two are same. Instead of water, we are using CO2. These all will be same. 2CO3. So this will be 2. Oh, here I don't want. 2, 3, 6. 2 here. Okay. Done. So this is in case of metal carbonates. Now let us see what is thermal dissociation. See, generally these reactions are not reversible, are non-reversible. But in case of thermal dissociation, it also comes under decomposition or the thermal decomposition or like decomposition reaction. And the difference between thermal decomposition and thermal dissociation is generally asked. Always. Thermal dissociation. The reversible reaction. The reversible reaction brought the reversible decomposition. Brought by heat. Wherever the word thermal is used means the word heat will be used. These are in relationship words. Okay. Now let us see another type which is displacement reaction. In this, the metals with higher reactivity reacts with a less active element. The element, the metal. Here no element. Metal with high reactivity reacts with low reactivity. Okay. For example, iron plus CuSO4 gives. In this case, which metal is of higher reactivity? Yes, iron. So this iron will react with this and give FeSO4 plus Cu. See, basically displacement reaction means that you are someone's friend. Okay, you are someone's friend, but another girl, you felt that she is more better than who is your friend currently. So what you are doing now, you are having power and you are having love. So you are attracted. So you became friend with that another girl, and then she was left alone. So there was the displacement. Similarly here also, nothing so special or different. Okay, so here also the same thing. Okay, now let us see the third type, which is a double decomposition reaction. Sorry, the fourth type. There are, as I said, there are basically four types of types of chemical reactions. So this is the last one. Which is double decomposition reaction. We call it a double displacement reaction also, but generally it is of I call it double decomposition only, because, but why do we call it double decomposition or double displacement? Because here both decomposition also, displacement is also taking place, so that is fine. Now this is also of two types. First is precipitation reaction, means that here the precipitate will be formed. Now what is precipitate? An insoluble solid. In this there will be aqueous solution. aqueous solution. Okay, for example, NaCl plus AgNO3 with none, which is more reactive, the sodium than silver. Metal. This is not the metal, this. So what will the sodium do? It will displace, it will remove silver because it is attracted with nitrate. So that is why it will form NaNO3, and then what is left behind? This Cl and Ag. So then they will think that okay, let's only make one if others are not accepting it. So AgCl. This will be the bond. In this, which one is the precipitate? This is the, for precipitate downwards arrow we write PPT also, and this is of white color. White precipitate. Now the another type of double decomposition reaction is neutralization reaction. Means that in this, okay, a second. What happens in second? Neutralization reaction is that here there will be formation of salt and water only. Okay, so for example, we can take which example should I? Okay, I'll take the easy example. NaOH plus HNO3. This will see the reactant will be one hydroxide with one acid. Generally this oxide hydroxide with the acid. Generally it is this. Okay, so this now, as here none is the metal. None is the metal over here. So sodium being powerful here, most reactive, want to take this nitrate. So it will form NaNO3 with H2O. Means that this is the salt over here. This is only the condition for the neutralization or double decomposition reaction. Okay, so this is the end of the chapter, and if you have any doubt you can comment in the comment section below. Thank you.